So how do we use the idea of the unit circle to find the values of the trig functions for common angles? Here's how we're going to do it. Let's look at some examples. Here's a picture of a circle, and this is intended to be a unit circle. Unit circle just means, the word unit just means that the radius is 1. So if you start in the middle and go out to any point, you go a distance of 1. Since it's a unit circle, I'm just going to identify some of the points on it. Since the radius is 1, this distance is 1, which means that the point over here has coordinates. Well, the x-coordinate is 1, and the y-coordinate is 0. Similarly, up at the top here, the x-coordinate there is 0, but the y-coordinate is 1, because this is a radius, and the radius is 1. Now, to the left here, we're once again on the x-axis, but now we're on the negative side. This distance is 1, but it's going in the negative direction. And so the coordinates of the point here are -1 for x and 0 for y. And then finally, down at the bottom, the point here is the point where x is 0 and y is -1. Now, those are sort of the most easy and readily identifiable points on the unit circle, and this already gives us a great deal of information. So let's just take a look at what this tells us. If you remember, when you have a point on the unit circle, that point has an x-coordinate and a y-coordinate, and those x and y coordinates are quite closely connected to the trig functions. In particular, the x-coordinate is is cosine, and the y-coordinate is sine. So when I think of this point here, well, what angle is this point lie on? Well, it's the angle is just the one that goes directly off to the right. This is an angle of 0. It's the same as the angle of 360, I guess. It's the same angle. So, in radians, we would call that angle 0, or we would call it 2 pi. This angle, when you intersect it with the unit circle, we have the coordinates 1 and 0, and this is like the cosine of that angle, and this is like the sine of that angle. And what does that tell us? That tells us that the cosine of the angle 0 is 1. Sine of the angle 0 is 0. Now, if we move up to the top and we consider this angle, the angle whose terminal side goes directly up, this is a 90-degree angle, or in radians, it is an angle pi over 2. That's the angle we're talking about. And on the unit circle, that terminal side intersects the unit circle at these coordinates, and this is, the cosine is x and sine is y. So here we have that cosine of the angle pi over 2 is equal to, well, the cosine is the x, so the cosine is 0. And sine of the angle pi over 2 is equal to 1. So that's like the cosine and the sine of 90 degrees, or pi over 2. Similarly, over here on the left, if we look at the angle 180 degrees, or pi in radians, this angle pi, well, the cosine is going to be -1, and the sine is going to be 0. So here we have cosine of pi is -1, sine of pi is 0. And by looking at the point down at the bottom, this is the angle, it's 270 degrees, or it is 3 pi over 2. That one has cosine 3 pi over 2 is equal to 0, and sine of 3 pi over 2 is equal to -1. So if we just focus on one of these, either sine or cosine, let's look at cosine first. All right. If we think about the angle 0 here, the cosine starts out as 1. And I think of that because sort of for this angle, everything about this angle is pointing to the right, so everything goes into the x movement, the x coordinate. So it's all equal to cosine is equal to 1. Now, as the angle increases, the cosine, which is like the x-coordinate, is getting closer and closer to 0. That means if you think about a point here and the x-coordinate, the point of the x-axis, is getting closer and closer over to the origin. So as we trace out a point here, as that gets closer and closer to pi over 2 or 90 degrees, cosine goes from 1 down to 0. Now, if you just think about, as this point keeps moving, think about what the x-coordinate does. The x-coordinate is still going, the point is still going to the left, so the x-coordinate is getting smaller. It's now getting more negative. It's going off in this direction as we move here. So that x-coordinate is getting closer and closer to -1. So it goes from 0 down to -1. That's the lowest point that cosine reaches, is -1. And then it sort of turns around and starts heading to the right again, which means it's getting bigger. So if you think about the x-coordinate of this point, it goes back up to 0. Here the x-coordinate is 0. And if we go even farther, here the x-coordinate grows all the way back up to 1. And in that journey, all we were doing was looking at the x-coordinates of these. It went from 0 down, it went from 1 down to 0, from 0 down to -1, from -1 back up to 0, and from 0 back up to 1 when we come full circle. So as the angle goes around the full circle, as the angle goes from 0 to 2 pi, or from 0 to 360 degrees, cosine starts at 1, it goes down to 0, down to -1, up to 0, and back up to 1 again. We can do a similar thing for sine. Sine is quite similar, except that here, where the angle is 0, sine, which is the y-coordinate, sine is 0. So the sine of that angle starts at 0, and then if you think of the sine as being like the y-coordinate of this point, the y-coordinate is getting bigger and bigger as I move until it reaches its maximum height, which is 1. Then as it continues to move, the y-coordinate gets smaller again until it reaches 0. There's sine is 0. And then it keeps going down underneath. So here the y-coordinate is -1. And then back up, the y-coordinate is 0 again. So as we travel around the circle from 0 to 2 pi, sine starts at 0. First it goes up to 1, back down to 0, and then it goes down to -1 and back up to 0. Those are like the values of the trig functions at sort of the easy points to identify on the unit circle. And what I want to do is I want to take one more point and just talk about what is it that's involved in figuring out the coordinates of this point. So if we take an angle that's in between, let's do a 45-degree angle. That one should go right about there. And for that 45-degree angle, what is 45 in radians, first of all? Well, in radians, 45 degrees is pi over 4. And the corresponding point that we get on the unit circle, we're wondering what its coordinates are. Question mark. We would like to fill in the coordinates. If we can fill in the coordinates of this point, the x-coordinate of this point will be the cosine of this angle, and the y-coordinate will be the sine of this angle. Now, here's what we know about this point. It's on the unit circle, and the angle here is 45 degrees, or pi over 4, and it's on the unit circle. Now, on the unit circle means that this guy, the hypotenuse, is a 1. That's like the r. Everything on the unit circle has r equal to 1. And the way that we can consider this is by making a triangle picture. If we extend that point down to the x-axis, that gives us a nice right triangle, and it's just up to us to figure out what is the distance across the bottom and what is the distance here when this angle is pi over 4 and the radius is 1. Okay, This is not obvious at all. We've moved a distance of 1 this way, but it doesn't mean that we're going to get a 1 here and a 1 here. If you move 1 for x and 1 for y, you actually get a point that's on the same line, but it's too far away. It's more than a distance of 1 away. But what you're going to find is that these two numbers are the same. It's just that we have to sort of scale them back so that the distance away from the origin is only equal to 1. And figuring out what those two are, that's tricky. And that involves looking at this and noticing the angles. This is a 45-degree angle, a 45-degree angle, and a 90-degree angle. And there are two very special triangles that we use. One of them is a 45-45-90 triangle, and one of them is a 30-60-90 triangle. And for this one, we would use a 45-45-90 triangle. We would draw it like so. I'll put these in degrees because that's maybe more familiar as you've dealt with these. If that's a 45, and that's a 45, and this is a 90, there's a special rule as follows for 45-45-90 triangles. They say that if the bottom and the side are each of length 1, and we know a squared plus b squared equals c squared, you can figure out what that c is, and it turns out that it's radical 2. Now, here's the trouble, is the hypotenuse here, the hypotenuse, this is like this guy, except that, unfortunately, this is too long. Radical 2 is 1 point something, and we would like the triangle only to have length 1. And so what we can think about is the definition of sine, cosine, and tangent. It works even if the radius is not 1, even if that hypotenuse is not 1. It's just that we have to do a division. So the cosine is equal to the bottom 1 divided by that r, which is radical 2. So cosine of this angle, 45 degrees, is equal to 1 over radical 2. The 1 comes from the bottom, the x-coordinate, and the over radical 2 comes from the hypotenuse. And similarly, the sine of this angle, sine of 45, is equal to the vertical side, 1 divided by radical 2. So this is also 1 over radical 2. What is 1 over radical 2? You could use your calculator to get a decimal approximation for it. It's a number that is between 0 and 1, and it's a little bit bigger than a half. So what do we have? Well, this has shown us that the cosine and the sine of 45 degrees, and maybe what I'll do is just change those 45 degrees. Since we're working in radians, cosine and sine 45 degrees is the same as pi over 4 radians. So cosine and sine of pi over 4, this is like the x-coordinate of the point on the unit circle, and this is the y-coordinate of the point on the unit circle, and they are also the cosine and the sine of that angle. Let me see. If I'm able to zoom in, I can maybe put in 1 over radical 2 here. Let's see if I can do it. Much tinier. So this was 1 over radical 2, comma 1 over radical 2. Okay. So this is meant to be an example, and what the idea is to show you is if you draw an angle that's not 0 or 90, pi over 2 or pi, so on, for these sort of in-between angles, sometimes you can figure them out by making a triangle and noting that the angles form sort of a nice triangle, a triangle that we're familiar with. 45, 45, 90 triangles are some of them. Another one is if you make the triangle here, where this initial angle is 30 degrees. 30 degrees is pi over 6. Then you get a 30, 60, 90 triangle when you draw this, and you can do a similar thing with a 30, 60, 90 triangle. Draw the triangle. There is a rule for 30, 60, 90 triangles, just like there's a rule for 45, 45, 90 triangles. And that appears in the lesson, both in the book and on the webpage, but I'm not going to go through it here. But it does allow you to get the sine and the cosine for the 30-degree angle as well. And a similar strategy works for 60-degree angles. and so on. And then as you're working your way around the unit circle, if we want to look at the angle that goes over here at a 45-degree angle, but to the upper left. So it's like the one we just drew, but it goes in the upper left in the second quadrant. The idea is this angle, this is the angle 135 degrees. It's also the angle 3 pi over 4. So maybe I'll just change the color so we can see it more clearly here. This angle is the angle 3 pi over 4. And that's the angle that goes from the positive x-axis over to there. If we want to know what are the coordinates of that corresponding point on the unit circle, well, we're looking for this point right here, the coordinates of this point. And the nice thing about this picture is that once we figured out this one, you'll notice that this is just a mirror image of this. It's been flip-flopped over this vertical line, over the y-axis. It's been reflected across there. It's just a perfect mirror image there. And what that means when we flip it over there is that the y value is just the same. That is, it's the same height above the x-axis here, which means that the y value of this is this guy. It's 1 over radical 2. And the x value, you can tell that since this is on the left-hand side, instead of x being positive, x is now negative, but it's otherwise the same. So it's going to be negative 1 over radical 2. So let me zoom in again here. We're going to take another look. This one is x is negative 1 over radical 2, and y is 1 over radical 2. And we can use a similar strategy to obtain, and maybe just before we leave this, this is for the angle 135 degrees or 3 pi over 4. And this is the cosine is negative 1 over radical 2, and sine is 1 over radical 2. And we can similarly draw the angle down here. Here, both the x and the y will be negative, since the x is on the negative side of the x-axis and y is on the negative side of the y-axis here. And then over here, the angle that is halfway between these two, this angle is going to have a positive x but a negative y, and that's going to be like a positive cosine and a negative sine. Okay, that's the basic idea, trig functions for common angles in the unit circle. The next thing that we'll be doing is looking at how we turn these into a graph of the functions sine of x, cosine of x, and so on.